Hi there and welcome to another Python video. In this video we're going to take a look at grouping data in Python, and we're going to look at the itertools module, specifically the groupby function, and we're also going to take a look at Pandas, which also offers very good tools for grouping data in Python. So let's get started. I've got a Colab notebook open here, and this is a signature for groupby in the itertools module. It takes in an iterable, such as a list, and it takes in a key function which defaults to none. So let's get started with some coding. I've got the itertools module imported and I've defined a list of characters, or rather this is a string of characters. Strings are also iterable in Python, just like lists, and we can use these for the itertools.groupby function. So if I print these out just to show you what they are, obviously we've got some A's, then some B's, some C's and some D's. Let's group by the characters. So itertools.groupby, and I pass in the characters, and I'm not passing a key function, just the characters, and we get back a groupby object. We can convert this to a list using the list constructor, and that gives us back this interesting structure here where we have the distinct values within the character string as keys essentially, and we have also grouper objects, which is basically iterables containing all the grouped elements. So let's have a look at that in more detail. We can actually iterate over this. So if I get rid of the list there, I can say for key and group and itertools.groupby the characters, and this is what the group essentially is, and this is what the key is. This is a tuple that is returned from itertools.groupby, and we can look at that directly here. So let's print out the key, and we'll print out the group converted to a list, and you see that we get with each key we get the associated values that occur in the characters. So that's how we look at the key and the value. That's what itertools.groupby does. One of the key observations about itertools groupby is that it has to be sorted first, and you can see that the characters are sorted. This will look at these characters one by one, and when it sees a new one that it hasn't seen in the previous character, it creates a new group for that character. To demonstrate this, if I added a B here and we ran this, you see that we get A, then it encounters a new character B, and you see that there's a new group for that. Then there's two more A's and then B's, so that the A's aren't actually grouped together, which means that if you have an input to this groupby function, you must sort it by the associated key first. Now, because our key is just the identity function, we can just leave that key out and sort it by the letter. But if you have a data structure like a dictionary and you want to sort by a particular key in the dictionary, you would need to define that key function. So moving on, that's just a demonstration there that itertools.groupby, you really need to sort the input first. I'm going to bring in a new dictionary here. And this is a dictionary of people who have names, they have an age, and they have a city that they're from. And because, as I said in the previous example, we need to sort this dictionary by the key we're interested in, and that's going to be the city key. I want to group these elements by the city that they're in. So I'm going to sort the dictionary by the key, which takes in a function, lambda x, and it sorts by the city key in each dictionary. And as before, we can iterate over each key and group using itertools.groupby, and we pass in the dictionary there. And if we print the key and the group, we get back that the key is actually the full object. Now this is a problem. There is no grouping going on by any particular key here. We want to group by city, so we need to provide a key function. Remember, the key function by default is the identity operator, which is basically for a dictionary, whereas it in memory will be the identity operator, and they're all different, so we don't get any grouping going on. However, we want to group by city, so we can pass that in as the key, and then we get a different representation, and we can list out each group, and we get the ones in Chicago, or rather the one in Chicago, we get the one in Glasgow, we get the 2 in New York and 3 in Scranton, so we can actually group by the city and we can see the people who are in each city. Okay, now as a detour, I'd like to talk about Pandas. Pandas is a library for data analysis, and it has excellent tools for grouping data. So I can create a data frame from that dictionary, D, and we can view the head of the data frame as such. We get the people, the names, the ages, and the city. What we can do is we want to group by the city. We can simply say df.groupby, and we pass in city as the column name, and that will give us back a pandas group by object, a data frame group by object. But we can chain onto that a function such as mean, and because that will operate over numerical fields, we get the mean age, which is the only numerical field in this data frame, for each grouped city. So if we look at, for example, New York, the mean age is 43.5, and that makes sense because it's halfway between the two values of 32 and 55 that are present for New York. And we can also chain on other operations such as the standard deviation. Again, for Chicago and Glasgow, there's only one value, there's only one person in each of those cities, so we get not a number. But for the other two, we can look at the deviation there, and another aggregation operation we can do is the size operation, which tells us how many people are in each city. 1 in Glasgow and Chicago, 2 in New York, and 3 in Scranton. So that's a very short example of how we can use pandas to analyze data. We can group by any column we want, and then we can perform aggregation functions on that data that's grouped together. Now we're going to apply these tools to some real life data. What I've done is uploaded the IMDB top 1000 movies from the IMDB dataset that I've grabbed from Kaggle, which you can get here at this link, which I'll put in the description. And just to demonstrate that that's uploaded to Google Colab, you can list out the current directory and you should see the file there. So we've got that file available to us. We can now read that data in and do operations on it. So to read in a file, a CSV file, in this case we use pandas read CSV function, which is pd.readcsv, and we pass the name of the file, which I'm going to copy here, and that should give us a data frame. And you see we get back a data frame. The first column here of this data frame is just matching the index actually, so we're going to drop that using index call equals 0. That'll actually just set that to be the index of the data frame, and then we can store that in a variable called df. Now what I want to do is show you how we can maybe group by certain values. If we look at the head of this data frame, what we're going to do here is we're going to split out the director of this data frame. It's stored under the cast, and I'm going to copy a snippet of code to do that. This code will be covered more in my series about pandas, which I'm going to create. For now, all you need to know is that this looks at the cast column, and it uses an apply function to split out by the pipe and then split by the colon, which will get the text in between that, which is the director for the film. And then once we've done that, we store the value in a new column called director. So if we look at df.head, after performing that operation, we get the director column now appended to the end of the data frame. So the reason we're going to do that is because I want to group these movies by the director, and I want to see which director has the most films in the top 1000 on IMDB. So we can do that with this operation here. We group by the director column that we've just created, and once we've done that, we can simply chain on the size function, which will give us the counts per director. And you see we don't get that in any numerical order, it's ordered by the director name. So we can then sort those values with pandas sort values function, and we'll reverse that to get the highest first. And you can see the top director, the one with the most movies in the IMDB top 1000, is Akira Kurosawa, the Japanese director. We also have names like Von Trier, David Lynch in the top 5 here. And we can look at the top 10 specifically by chaining another slice onto the end of that, and we get things like Tarantino and Billy Wilder and others. So that's how you group by a director column, get the number of films each director has in the top 1000, sort those values in top to bottom order, and then look at the top 10. And we can also group by other columns. If we look up at the other columns in the data frame, we could group by, for example, the certificate function, the certificate column, simply df.groupby, we say certificate, and then again we could get the size of that, and we find out that The majority of films in the top 1,000 are rated R, and we have a lot rated which are not rated actually, perhaps foreign movies, and we also have a lot of PG-13 and PG. So that's another use of groupby there. Very simple stuff. Pandas makes it very possible to do a lot of complex grouping and aggregation, especially over numerical columns. This is a kind of whirlwind tour of that. I'm going to cover that more when I do a Pandas series soon, but for now it's important to understand the itertools module, which has a groupby function that's useful if you're wanting to use just standard library operations and you don't want to bring in a big library like Pandas. On the other hand, if you have Pandas and you're using data frames, then grouping data is very simple and very convenient. Using the Pandas groupby functionality, you can perform all manner of different operations. So it's very good to know about both of these. And that's going to tie it up for this video. Thanks for watching. If you liked the video, please subscribe, and see you again later on. Bye.